So in this section, 7.4, we're going to look at qualitative variables. So we're going to start out with problem 18 on page 328. The National Center for Educational Statistics reported that 75% of the freshmen entering public high school in the United States in 2007 graduated with their class in 2011. A random sample of 135 freshmen is chosen. Find the mean proportion and the standard error for this population. Well, in this particular case, the standard error, the mean proportion is P is equal to 0.75. And the standard error, which is given by the formula in the book, right, is the square root of P times 1 minus P divided by the sample size n. So it's the square root of that, which in this case is 0.0373. So now we're going to change the variable. When we look at p hat has a sampling distribution to it, which we call p hat, right? The center is at P, and the spread is its standard error, which is the standard error, which is the square root of P 1 minus P divided by the sample size. So now, the first question asks, find the probability that less than 80% of the freshmen in this group graduated with their class. So we have the probability statement. The probability statement in this case is the probability of p hat less than 0.8. We change that variable to a z variable, and you can see how that's done. Remember, z in this case is going to be p hat minus p divided by the square root of p 1 minus p over n, right? So this is the standard error. So that's what we're doing here. And then, of course, we look up on the table and we see we're looking for a z value less than 1.34. And when we look it up, it's approximately 90.9099, which is 90.99%. So the probability that less than 80% of the freshmen in this group graduated with their class is about 91% of the time. Find the probability that between 65 and 80% of the freshmen in this group graduated with their class. Again, when we look at the probability statement is 0.65 less than p hat less than 0.80. And if we really wanted to do this by hand, we could. The probability of p hat less than 0.80 minus the probability of p hat less than 0.65. But we're going to use the calculator, and the calculator will give us just as well the answer. Here is the lower bound, here is the upper bound. 0.75 is P, and our standard error in this case, which we found up above, is the last entry, and we get approximately 0.9063. So about 90.63% of the samples that are taken show that between 65 and 80% of the freshmen in each of the groups graduated with their classes. So we're looking at the same problem, problem 18 on page 323, and we have two more questions. It says find the probability that more than 65% of the freshmen graduated with their class. Here is our probability statement, and since our z-table only looks at probabilities to the left of p hat, we have to transform it first into a complement, 1 minus the probability of p hat less than or equal to 0.65, and then we transfer it to a z variable. And we've already done that in one of the previous problems. So we did that, 0.65 minus 0.75 divided by the standard error. 1 minus that, and we get 1 minus the probability that z is less than or equal to a negative 2.68. When we look at that on the table and do the calculation, we get 0.9963. So in this particular case, find the probability that more than 65% of the freshmen graduated with their class. That'll happen at least 99.63% of the time based on this information. Then, would it be unusual if the sample proportion of freshmen graduated with their class be greater than 85? We said yes in this particular case, so we set up the probability statement. And again, we do the same thing. We have to use the complement if we're going to do it by hand. And then we move it over to a z interval. And then from there we do the final calculations. And with the final calculation we get the probability that p hat is greater than 0.85 is 0.0037. And since that's less than 5%, it would be unusual. So we have a medical problem. This is problem 22 on page 323, blood pressure. High blood pressure has been identified as a risk factor for heart attacks and strokes. The National Health and Nutrition Examination Survey reported that the proportion of U.S. adults with high blood pressure is 30%, 0.3. A sample of 38 U.S. adults is chosen. The first question is it appropriate to use the normal approximation to find the probability that more than 40% of the people in this sample have high blood pressure? If so, find the probability. Well, in this particular case, the conditions for using the normality assumptions is NP has got to be greater than 10, N times 1 minus P has to be greater than 10. When we do the calculation, certainly we get them both over 10. So the normality assumptions work in this case, so we can use the normality assumptions. We will set up our probability statement. If you can see that, the probability that p hat is greater than 0.40. Again, if we're doing this by hand, we have to use the complement because we're looking to the left of 0.40 when we look at the z-table. Now we're transferring this to a z variable. You notice our standard error is the square root of 0.3 times 0.7 divided by 38. Then we get this statement, 1 minus the probability that z is less than or equal to 1.35. We look this up at the table, then we subtract 1 minus that, and we get about 8.85%. So now we notice that we're going to, in the second problem, in part B, it says A new sample of 80 adults is drawn. Find the probability that more than 40% of the people in this sample have high blood pressure. So we have the same statement, but the thing that has changed in this problem is the standard error. Notice that this standard error is going to be smaller, so that makes z bigger. And when we do the calculation, 1 minus z less than or equal to 0.195 is now about 2.56%. So in this case, if our mean value, let's look at the interpretation real quickly. If we're looking at our sampling distribution of p hat, and we notice that if we have mu, or in this case p is equal to 0.30, and we're looking at the value of 0.40, and we're looking at the area up here. When we did the calculation, we said that area is, based on this sample size of 80, is 2.56%. Up above, it was different. It was 8.85%. So notice that the bigger the sample is, the standard error, it gets smaller, which then makes our distribution smaller as well, closer and closer to the true value of p. So that's the difference between these two, Part A and Part B. We're continuing our discussion on high blood pressure. This is the same problem, 22, page 324, and number C says, find the probability that the proportion of individuals in the sample of 80 who have high blood pressure is between 20% and 35%. And again, here our statement is the probability that 0.20 is less than p hat is less than 0.35 is our probability statement. So we have an upper bound. There's upper, and this is lower, right? And so when we put it into our calculations under second vars, we get 0.8099, right? So samples that are of 80, in this particular case, about 81% of these samples will have people that have blood pressure between 20% and 35% high blood pressure. The next question is find the probability that less than 25% of the people in this sample have high blood pressure. So here is our probability statement. P hat is less than or equal to 0.25. We change it to a z value. Probability that z is less than 0.25 minus 0.3 divided by the standard error of the square root of 0.3 times 0.7 divided by 80. And now that gives us the probability that z is less than or equal to 0.976. When we look that up in the table, we get approximately 0.1635. So samples that are 80 that have on average blood pressure of 0.3, we'll see the probability that less than 25% of those in the sample have high blood pressure is about 16.35% of the time. Would it be unusual for more than 45% of the individuals in the 80 patient sample to have high blood pressure? Here's our probability statement, and we'll use the normal CDF 0.45, E99, 0.3, and then we have our standard error, right? Here's our standard error in this particular case. And the answer, of course, is yes. And why? Because this value is less than 0.05. Well, that concludes our problems in Chapter 7.4, Sampling Distribution.